So this quantity here is generally interesting. So I'm going to define F dot dr to be the work done by force F in being displaced by dr. So this defines an infinitesimal bit of work. So we have that the dimensions of work are force times distance, which is the same as energy. And if I were to consider some goofy displacement from a point A to a point B and ask for the work that was done in making that displacement, well, the displacement vector would be that one. Is it true that the work done is just the dot product of the force and the displacement vector? Does it only care about the endpoints?
Yes, for constant force.
For a constant force. Of all the class of forces, constant is a very narrow one. So in general, the force may depend on position. And so in general, we may have to break up the path into a bunch of little segments over which the force is not changing appreciably, and do an integral. So that's the bottom expression, that the work done in going from point A to point B along a particular path would be that integral of f dot dr. And then general, as we're going to see in the next chapter, that depends on the path. You see why it might depend on the path? If the force is uniform, then it won't depend on the path. But if the force is varying with position, it very well might. Okay? Okay. So what we have by this argument here, the change in the kinetic energy is caused by the net force moving through a displacement, and it's the component of the force that's parallel to the displacement that counts. Or you could say it's the component of the displacement that's parallel to the force that counts. And it's the work done by the force that produces the change in kinetic energy. Okay?